Here's a video about air masses and fronts. The essential question we are answering is, how do air masses differ and what happens when they meet? Okay, starting with the major air masses that affect North America. First, define an air mass. A huge body of air that has similar temperature, humidity, and pressure throughout. As of now, we're not thinking of our atmosphere as one solid continuous layer. Instead, you need to think of air masses as almost pockets or bubbles of similar air that's moving over the Earth's surface. Now, those pockets of air, those air masses, are going to have the characteristics of the land over which they form. So, if they form over water, they're going to be moist air masses holding more moisture or water vapor. If they form over land, they're going to be drier air masses. If they form towards the poles, they'll be colder. If they form towards the equator, they'll be warmer. So let's look at these a little more specifically one at a time. Okay, these lowercase m's stand for maritime. And if you look, those are the air masses that are all forming over water. So, maritime air masses will be more moist. If you look at the air masses starting with a lowercase c, those all form over land. The lowercase c stands for continental. Those air masses will be drier. Okay, the capital T's. Those are the ones that are red. The T stands for tropical. And those will be warmer air masses. Those are all forming towards the south. The capital P, that stands for polar. We are moving further north towards the North Pole. Polar air masses will be cold. We have one capital A, that stands for Arctic. The Arctic air mass is very cold. So all air masses are a combination of the two. There's maritime polar, that one's going to be cold and moist. Maritime tropical, that will be warm and moist. Another maritime tropical. Continental tropical, that one is dry and warm. Another maritime tropical, warm and moist. Maritime polar, cold and moist. Cold because it's further north, moist because it's over the water. Continental polar, above Canada, that one is cold and dry. And continental Arctic, all right? Very cold and dry. So all of these air masses, these are the ones affecting North America. These air masses are moving, okay? They are not locked over one particular area. They do move around in particular patterns, and when they bump into each other, that's what causes changes in weather. That's what gives us fronts, okay? Before we even mention the cold front, let's define the word front as a boundary where two air masses meet. Important to understand that when two air masses meet, they don't mix together. Okay, let's start with the cold front. If we hear that a cold front is moving into our area, then that means we are starting with an area of warmer air. Okay, so let's say that we're here, there's a warmer air mass covering our area. A cold front means a cold air mass is moving in. Now, one thing we know about a cold air mass is that it is heavier, it's more dense. When the cold air mass moves in, because it's more dense, that means it has the ability to wedge itself underneath the warm air. Now when it does this, it causes the warm air to be lifted up, pushed into the sky. So this is going to cause a couple of things. This warm air is holding more moisture than cold air. So all of this moisture is being pushed rapidly into the sky, which is going to cause thunderstorms. Not only that, but as this system advances, as the cold air pushes the warm air up, the temperature will drop. One more thing to cover before we move away from the cold front is what this symbol looks like on a weather map. Cold front is a blue line with triangles. The triangles point in the direction the front is moving. So, if this front is moving towards the east, these arrows point towards the east. Alright, let's go to a warm front. If we hear on the news that a warm front is coming in, that means we're starting with an area of cooler air. Now, since warm air is lighter, that means when the warm air moves in, it will rise above and slide on top of the cool air. Now, as the system passes us, the temperature will, like the name says, get warmer. And since we have moisture being lifted into the sky, we will again get clouds and precipitation. Now, contrasting this with a cold front, a warm front moves slower, and this rain is not as strong as the thunderstorm. It'll be a lighter rain that lasts a little bit longer. So that's the warm front. The warm air slides over the cool air, condensation, rain, precipitation, and this temperature will gradually rise. So over a couple of days, you'll feel a noticeable change in temperature and humidity. On a weather map, this is a red line with semicircles, bumps, half circles. If you're looking at a black and white weather map, just pay attention to the half circles. And just like the cold front, those are pointing the direction the front is moving. Okay, next up is the occluded front. This is actually a front made of 3 air masses. And it's really one front after another. Let's say that we're starting with an area of cool air. And let's say that a warm front moves in first. Just as before, the warm front comes in, slides above the cool air. The thing about an occluded front is that behind the warm front is a faster moving cold front. So it's a combination of 2 fronts, a warm front followed by a cold front. So as this front moves in, it pushes all of the warm air up away from the surface. So all of this warm air is actually cut off of the surface. And it ends up looking kind of like this. So we started with an area of cool air, the warm air came in and rose up, but then cold air came in and wedged itself underneath both air masses. So now we have the coldest air underneath the cooler air, and that cut off all of the warm air from the surface itself. So that's going to cause a drop in temperature. And again, light rain. Okay, the occluded front on a weather map, if your weather map is in color, is a purple line with alternating triangles and half circles going in the same direction. Okay, the last front, a stationary front. Stationary front is a warm air mass moving towards a cold air mass, and just like the word stationary means not moving, these 2 air masses come together and they basically come to a dead stop. Okay, so neither one rises, neither one sinks, neither one dominates the other. So a stationary front, two fronts come together, meet in the middle, and stop. Like with all fronts, you will get precipitation, but the change in temperature really depends on what side of this front you're moving on. So, two fronts meet in the middle, stop moving, that's your stationary front, and they can be stuck there for a few days. On a weather map, you have an alternating blue line with your cold front pointing the direction it's going, and then that is alternating with the red line. So the blue points the direction of the cold front, the red half circles points in the direction of the warm front. Keep in mind that most weather maps you guys will see are black and white. So if this were black and just a black line, look for the triangle and the semicircle going in opposite directions. As with the occluded front, you'd have to look for a black line with alternating triangles and circles but going in the same direction. So we've covered the four fronts. A little bit about weather maps. There's a couple symbols we haven't mentioned yet. Okay. The cold front we've talked about, the warm front we've talked about. That leaves three symbols that we haven't mentioned yet. These solid black lines that kind of remind us of lines on a topographic map. These measurements, and then your H's and L's. Okay, the L stands for a low pressure area. A low pressure area is where warm air is rising, and we know that warm air carries moisture. We know that moisture will condense in the form of clouds. So low pressure is associated with cloudy skies and rain. Okay? Your capital H, that is the symbol for a high pressure area. That is an area where all of the air is sinking down towards the ground. It's heavier. Now, if all the air is being pushed towards the ground, there is not any clouds in the sky. Okay? So, high pressure is associated with clear skies. If all of the air is sinking, that means there's no moisture in the air to form condensation. The easiest way to remember the L and the H, think heavy, the air is sinking. L, think light, the air is rising. Light air that rises will form clouds and rain. Heavy air that's sinking will give you clear skies. Okay, and now for these dark lines. Those lines are called isobars. Okay? Bar refers to pressure. So these are lines that show us measurements of atmospheric pressure. Any point along one line will have equal pressure. Okay? The measurements are known as, that's your measurement of pressure measured in millibars. Okay? So, it shows us just what the atmospheric pressure is in an area. A little rule of thumb, the closer those lines are together, the windier the conditions will be. So the closer these lines are, the higher your wind speeds. Alright? And I believe that about covers it.